welcome to our first community call. We will be doing these every 2 weeks to our aim is to give you updates, also start connecting with our community, answer your questions, which we will be releasing forms right before the community calls where you can put in your questions and we will answer them every 2 weeks in these community calls. I will also introduce Diego. Most of you probably know him from our spaces and other type of calls. He's our head of research and co-founder. I'll let him introduce himself a little.
Hi, hello. Nice to be here with you. It's going to be a pleasure to have these spaces to discuss with you some of the updates and also be able to answer some of the questions you may have regarding zk technologies or what we do. We want you to be tuned with the latest developments. And well, as Geeny introduced me, I am one of the co-founders and head of research. My path has been a bit weird because I studied originally chemical engineering, then I decided to work on cryptography. I was head of research at Lambda class for some time, and now we have this very cool project that I think will help solve some of the big issues we encounter in zk adoption. And so happy to share every development and everything with you.
Cool. I forgot to introduce myself. I'm Geeny. I'm in the ecosystem team for like community and strategy, and we also have a SOP, Alex. He's leading the operations of this community call, and he's in our marketing team and growth. So I'll start with some updates we've had. We've also shared them on Twitter, but I also want to go through them again anyways. First of all, we're on a third stage on our testnet, I believe, if I'm not wrong, Diego. Yeah, so far we've had 3 testnet stages and we're getting ready for the mainnet. Maybe in a month or 2, or that's our aim. And in terms of numbers, so far we've had 24 partners. We're gonna announce 2 more today, I think. We've had 28 registered operators on our testnet, 130K verified batches, and 28 million proofs, growing by the day. Yeah, we had some questions already filled out in a form as for the answer in the chat, but we will have some time for you guys to ask some questions too here after we've gone through the ones that are already submitted. In other updates, Diego will mostly give you any technical updates, but soon, another reason we're also having this community call is that soon we want to start a community program for people who want to contribute. It's like an ambassador program. We haven't decided what to call it yet, but it'll be a good opportunity for some of you who's been asking about how they can contribute or what will happen to the OG roles and things like that. We'll start soon iterating on them and releasing some programs for community contributors. And in terms of technical updates, there are quite some questions about our roadmap and about the testnet in the file, but in terms of maybe audits or any other technical updates that Diego might want to give, I'll pass the mic to him.
Thanks, Geeny. So right now we are in the middle of receiving audits from different teams. So far, we are very happy with their work and the feedback we've been receiving. We've been addressing everything that they said. Of course, then we are going to share some of their findings or so that you can see all the work that's being done. Of course, you can always follow the development of our library in GitHub because it's open source. You're going to see everything is done in a very transparent way. So, of course, you can check how we are addressing the different issues that have appeared. So the priority right now from the technical team is related to solving these things to be able to go to mainnet. But then, of course, we are already thinking on the next stages, doing like the design for the second part, because right now the objective is to have our first product, which is what we called the fast mode or proof verification. Okay, that is the one we mentioned using risk taking and using this decentralized network of verifiers that when they agree, they post that the proof is valid to Ethereum, and then you can use the result. But we have the second part, which is this proof aggregation service where we do proof recursion. We bundle many proofs together, and that proof gets verified directly in Ethereum, as opposed to the fast mode where the main verification is done by the operators, okay? And then the signature gets verified in Ethereum. Of course, we are also trying to finish a small blog post explaining the roadmap more detailed so that you have like more time to process and of course ask more questions. And then we also will have like some updates regarding, for example, the architecture for the Mina bridge, which is going to be one of the first use cases of Alliance Fast Mode. It's really interesting. And of course, we will also be sharing a lot of technical posts on different topics related to cryptography or to some of the primitives we are using so that you understand all the technology we are going to be using. And we are also going to release a new version of the white paper, okay, with the more detailed architecture, including the payment system and all other things, so that again you have all the information updated, and that's mostly it, I think.
Thank you, Diego. That was great. Another thing we also did recently that I just remembered is we have a new product within Align called zkRust. I've used it and it works. If you want to give some information about that, also would be nice.
Yeah, that's great. Well, so we've seen that over the last few months, there have been like many CKVMs that basically are able to prove code that you wrote in a higher level language, for example, in this case, Rust. Okay. And so you may be wondering, okay, which one is the best to use, or which do I use for aligned or whatever. So what we wanted was to somehow uh, build something that with just one command, you just send your code written in Rust, it gets executed on one of these CKVMs, and then it gets sent and verified in Aligned. So if you want to generate just a proof for one of your programs or applications, you don't have to worry about many of the details. You just care about coding in Rust, and then using these very simple commands, you can send it to the proof generation, and then it automatically sends the proof to aligned. So as Geeny said, she's been testing it and it works. So that's something really nice. Of course, we are going to add like other popular CKVMs. Right now, I think we have support for 2 or 3. But our objective is that you have like several options and that you can choose, or you can, for example, set a default or anything. This is just to make life easier for developers. You just focus on coding, and something else is going to focus on or deal with the CK aspects, so that again you focus mostly on code, and Aligned just verifies it.
Or even non-coders like me. I don't code, but I thought it was pretty cool to be able to use these things and generate my own proofs that I can use with anything. So we're mostly done with the latest updates. There are a few things, but I think we will get more in depth to these subjects, like the ambassador program, in our next community call. And we have quite many questions, so I'll start with those. There's a cool question. It's an easy one, but since we didn't explain aligned that much, probably thinking you all know a little bit about it, but it'll be good to go over it again. How do we compete with similar products? Well, what are our advantages? I'll let Diego explain it, but I think it'll be cool to emphasize on our 2 features, like slow mode and fast mode, and what they are and what makes us different from some other people trying to do aggregation.
Okay, so remember that one of the objectives is to reduce on-chain verification costs, trying not to sacrifice other things. Ideally, what we would like is a universe where we have very high throughput for proofs, very low latency, and low costs. Okay, so those are the 3 things we would like. Of course, one strategy to reduce on-chain verification costs is to do what they call proof aggregation. Okay, so remember that with zk we can generate proofs for programs, and one such program could be the verification of 2 or more proofs. Okay, so what we can do is what we call a recursive proof, that what we do is we prove that we verified 2 proofs, and then, for example, if we verify that proof, the later proof, this implies that the 2 previous proofs were true. Okay, the only problem that you face there is that you have to do this proof of a verification, and that is computationally expensive. So you just verify like n proofs for the cost of 1, but you have to do all these operations, and this takes time and is not always like very straightforward, because you may want to combine like proofs from different proof systems. So that may be a bit complicated. Okay, that is something that for example CK rollups typically do. For example, they generate like smaller proofs for the transactions in a batch, and then they generate one aggregated proof for all these smaller proofs. Okay, but the problem is, of course, you don't have the low latency because it's computationally intensive, and at the same time, because it's rather slow, you are not going to get very high throughput. Okay, but it's a way of doing it, and you inherit the full security of Ethereum. It's like verifying like all the proofs together. And that's why in Aligned we also have, or we want to have, this proof aggregation service. Okay, now the problem with that is we are not addressing maybe the problem of latency and very high throughput. So that's why we decided to develop something that others can't offer, which is this um, fast mode, which works with restaking. So what we do with the fast mode, and that's I think one of the main differences from Aligned with respect to other projects, is that we just have a decentralized network of verifiers. We just receive proofs from many different users, projects. We don't do anything. We don't do any pre-processing or anything. You just send your proof from the proof system you like, and we batch them together. We we create a new task in Ethereum, and then the verifiers, what they are going to do is download the proofs. Each one of them is going to verify each proof. And if all the proofs are valid, what they do is they sign a message containing the root of the batch and say, this batch is okay. So then is sent to an aggregator of signatures. We aggregate the signature, we post the aggregated signature to Ethereum. Ethereum says, okay, this is valid. And so it gets updated. So in this case, what you get is very low latency. You don't have to do anything to the proofs. You can mix together Graph16, Plonk, Starks, or whatever you like. Very high throughput. We've tried and we can reach even 4,000 proofs per second or more. And very low costs because we can make even bigger batches. So I think that's the main difference and the main advantage. And you are going to see this fast mode going to mainnet really soon. And we hope to have our proof aggregation service rather soon.
Thank you for the amazing detailed explanation, Diego, as always. Another question. Wow, okay. How is the security analysis performed for the zero knowledge proofs mechanism used in EigenLayer? Specifically, what are the potential attack vectors and mitigation strategies in scenarios where, what are the potential attack vectors and mitigation strategies in scenarios where zk rollups are integrated? What specific algorithms and protocols are used in the integration of verifiable computation with EigenLayer? Can you provide details on the advanced limitations of these protocols in terms of computational efficiency and accuracy? Should I write this down?
Okay. I think I can make like an answer. So, of course, the security you get is the security provided by your proof system. Okay. What we do is we just integrate the verifiers to aligned. And of course, if the verifiers are like well written, audited, and all that, then there is a very small chance, really negligible, that you'll get, for example, a false proof and pass. Okay, but one thing that you should take into account was that many projects, what they did was they just had one proof system and sent just one proof from this proof system because verifying proofs is really expensive. Of course, some people started saying like, why don't we use something like multi-proving? So if we want to submit a proof of our block or something, instead of sending just one Plonk proof, maybe I want to send a Plonk proof and a Stark proof, or even use a T proof or attestation. So with aligned, verifying proofs becomes really cheap. So what you could do is even like if you don't trust or you think that your proof system could have a bug or you want to cover against that, what you could do is have redundancy, have two different proof systems, send the two proofs, and if both proofs are verified in a line, are successful, then of course you have this redundancy. Maybe you had a problem, they discover, I don't know, that Plonk had an issue, but again, the Stark proof passed. It didn't depend on any trusted setup or anything. So of course you have these extra confidence. We are, of course, receiving all the security audits for the code. The good thing is that the fast mode is really like simple in its construction, so it doesn't have like many attack vectors really. Um, because if you try to attack, you'll have to either break, for example, the VLS signatures or generate one of these false proofs for any of these proof systems, which of course right now, if the verifiers are well written and everything, it's negligible. So in that sense, we are like super confident, and I think that this will help, for example, adopt multi-proofs, because if the cost of verifying one proof is really small, maybe you can say, give me two for the price of one, and so it's going to be fine.
Cool. Our stage is almost full. Very cool. Okay, another question. Cool. We have a question about teas. And if people don't still know it, we're also supporting tea attestations now. So we have widened our area of, sorry. In aligned layer, how are trusted teas, trusted execution environments configured to handle memory protection and data encryption? How do these configurations address potential performance bottlenecks? And there's another question within question. Can you provide detailed, I guess you just answered this. It's also about the structure and algorithms used in the state proof and state validation process. And how do these data structures affect blockchain performance and ensure data accuracy?
Okay, so yeah, the original objective of Aligned was to be a CK verification layer, but then we realized that in fact what we want to provide is integrity, to show that things are done correctly, even when nobody's watching. Okay, so what we can do is just, of course, TEs are not included in this version of the fast mode, but the idea is that we hope to include them really soon in one of the updates. And the TE just generates this attestation saying that the computation was done without interference from anybody outside and according to the code they had. And we can just verify that attestation and show that it is true. Okay, because if you want to verify attestations in Ethereum, it's like prohibitively expensive. So the objective of Aligned, or the idea of Aligned, is really to be this integrity layer. No matter which method you are going to use to secure your computations, you can always check it in Aligned, very fast and really cheap. Um, so we still have to think a little bit about how we are going to include it and which things we are going to support, but we know that some projects already are using TEs because it offers like some advantages in terms of speed compared to CK proofs. So maybe if you want to do like a very expensive computation that right now you cannot handle with CK, of course you can perhaps accept TEs, or even you can have TEs as a secondary system to secure your construction. Okay, so you can have these multi proofs, but having like, for example, a TE attestation and a SIGI proof. But we will share you like the updates in the blog post for the roadmap. We are really excited about all that is going to come in the next few months.
Um, okay, amazing. We have so many questions, by the way. We might not be able to answer all of these, but make sure to resubmit them if your questions don't get answered. Interesting question again. There are some really interesting questions, by the way. How does Align address the challenge of evolving data schemas? Is that how you pronounce? Schemas and structures while maintaining data quality and observability? I guess it's still a similar question. How does Align balance the need for real-time data observability with the challenges of data volume and complexity? Does that make any sense?
Yeah, maybe, but I think that one of the advantages you have in Aligned is that you can submit, for example, proofs that are like much larger than the ones you can, for example, submit in Ethereum. And that is because we avoid like some of these traps, and of course we can then share the details of how we are like storing the proofs and making sure that they are available for all the operators to download. um, yeah.
Hmm. The the current market seems to be focusing on L2 rather than L1 itself. Is there any plan to expand to non-zk L2 or anything? Align could also help with non-zk L2. I think this guy misunderstood some things.
Yeah, but I think that of course we are starting to see uh, an interest to use Align, for example, to bridge between different L1s. It will be the case for the MENA to Ethereum bridge. And we think that, of course, with the first successful cases, then many more will follow. We also know people that want also to have their results propagated to a particular L2. And of course, it's going to be possible. And so they can use the results in whatever L2 they like. And I think we are going to help solve a lot of the issues related to interoperability and fragmentation in Web3 space. Okay. Um, so yeah, I know that maybe a lot are focusing a lot on L2s, but the good thing is that with Aligned, we won't need to make like many changes to add like new proof systems or even use Align to circumvent some of the limitations of the EVM. Uh, Again, in the MENA bridge, you're going to see like some interesting use case of Aligned to go around the fact that you don't have certain precompiles in the EVM. So happy to share more on the blog post. We are going to be discussing and showing a little bit how we can deal with really complex problems.
Oh, my microphone was on. Okay, another question. In the context of EigenLayer's approach to zero-knowledge proofs, what specific technical innovations allow for the reduction of proof verification costs by up to 90%? And how might these innovations impact the scalability of Ethereum?
Well, the good thing is really to have this very high throughput. We didn't need like any specific like advance in zk technologies. That is because proof verification is really, really, really fast. Okay, typically a Groth16 proof or a Stark proof or a Plonk proof takes more or less 1 millisecond. Of course, it depends on your hardware, but typically they are really um, fast. The problem with verifying the proofs in Ethereum is, of course, that you have to run on top of the EVM, and they have a rather large gas cost, which of course limits a lot the throughput. In our case, we are running the verifiers already on bare metal. You can leverage parallelization. You can take advantage of many other things. Of course, your verifier in Ethereum is optimized for gas usage, whereas in Aligned, it can be optimized for speed. Um, so that's why we can get a very high throughput compared to Ethereum or other solutions. Of course, there are like some nice developments that we are going to see. For example, um, all that has to do with circle starks or binary fields that have very fast finite field arithmetic. Probably this will make that verification is a bit faster, okay, and so maybe you can process even higher throughput. Uh, but really, I think that we are already really fast, and with the current throughput, I think we could like help scale to another level. Of course, then we have to think, okay, maybe processing like even an even higher throughput, but still we think that there are like some strategies you can use to increase it further. And of course, then I think that proof aggregation is going to get way better, but still Alliance fast mode will help like check these proofs really fast. And maybe what we get is very fast aggregation of several proofs, but still to get the throughput, you're going to leverage Align fast mode. Okay, so maybe you are processing, I don't know, 4,000 proofs per second, but these are like larger proofs. Uh, but still, we need to first unlock this first milestone, which is reducing costs by over an order of magnitude. And then I think people will start finding ways of adding zk and using these technologies in ways we don't foresee. Okay, we all, of course, we know several use cases of zk, but what we think is that if these costs are really low and adding zk is really easy, of course we will find people, or we will have people finding new ways to add this technology, much as what we had with internet and the broadband. Okay, if you were asked, okay, what is the difference of having like the broadband to you're going faster, but nobody could foresee that you would have like social media, YouTube, and many other network effects. So we hope that this becomes some sort of broadband moment for zk.
Cool. Um, what? Okay, sorry. There's a few of the similar questions, like how does aligned layer make proof verification faster and cheaper? And I do advise everyone to check the docs for what fast mode does. Can we say that aligned is the end game when it comes to zk proof verification? Yes, I can answer that. Potentially. I guess it's a pretty general question, but what is Align's long-term vision for the intersection of zk-T and verifiable computation? How does Align prioritize between research, development, and implementation when working on cutting-edge technologies?
Well, in our case, we are like right now focusing mostly on engineering implementation. We want to have something that is really easy to use for everybody, very clear, and we want to focus mostly on that. Of course, um, as always, research is important. We want to bring like cutting edge research closer to people. If you want to see a bit our vision on how MPC, FHE, CK are going to transform the future, we have um, a very interesting post. It's on the Lambda class blog post. It was something that we were working with Fede, co-founder of Aligned. Um, and we are going to see that in this future where we see that there is a lot of questioning of institutions, um, advancements against privacy, and in fact that it's hard to trust, and also with the rise of what we see as AI generated content and all that, all these technologies will help uh, mitigate some of the negative aspects that have to do with the rise of these technologies. Okay. Um, so in this sense, we are excited by all the developments. Uh, we are trying to also like bring like new some developments to enhance in particular what is the proof aggregation service, which is going to be our next focus. And then, of course, we are working closely with other teams to bring new solutions. But I think that the nice thing about Aligned is that we think we are going to help other teams adopt CK and precisely unlock these new use cases that right now we don't foresee. That is to say, I am really excited about all the use cases we already have, but if I had to choose about something, is maybe uh, about all the things that I don't know that are going to come. That's why I decided to join and work on Align, because I see that we have a potential here and that CK is going to provide something that we want as people, which is integrity, fairness, showing that things are done properly and that we don't have to necessarily trust, because we have this technology that allows us to and be sure that, for example, our financial system is behaving properly, and that, yeah, I don't know, it's rather philosophical, maybe. Maybe we can do a separate call to talk on philosophical points. It's always fun to hear other people on on why they believe this technology is going to change the future. But we can continue later.
I'm totally down for the philosophical community calls. um, hmm. What specific, well, we did talk about this, but I'll connect it to another question. What specific advantages does Aligned offer over traditional Ethereum verification methods in terms of cost and speed? And how does the integration of EigenLayer enhance this? Yeah. And the potential implications of EigenLayer's ability to verify 1,000 proofs per second for decentralized applications on Ethereum. Yeah. Should, should I should I repeat the question?
Yes, sorry.
Oops. Oh, sorry. Okay, so we already answered the first sentence, but I will connect it to another question. What specific advantages does EigenLayer offer over traditional verification methods on Ethereum in terms of cost and speed? How does the integration of EigenLayer enhance the functionality of aligned layers verification for zero-knowledge proofs?
Okay, so in the case of EigenLayer, of course, it's like it provides like the core part of the fast mode because we can build these what we call actively validated service AVS for proof verification. So if we wanted to build, for example, an L1 for proof verification, then we would have like several problems. First, we wouldn't be building on Ethereum, and then we would have to bootstrap the security of the network from scratch, and of course get users and all that, and that's at the one of the hardest parts in blockchain space. So with EigenLayer, what you can do is rent or tap into the security of Ethereum without competing for block space. So what we can do is, thanks to restaking, people can say, okay, with my stake, I am going to add some additional slashing conditions to participate in this service. If I misbehave, then I am going to be punished. So with this, what you get is the possibility of building really cool stuff on top of Ethereum, inheriting or renting a part of the security of Ethereum. And really aligned is one example. I think it's one that is I find like particularly exciting. But of course, then you have other very cool things you can build using EigenLayer because this opens what they call in their paper these infinite sum games. So what you can start building are different like services on top of Ethereum that then you can combine to build this new type of Web3 uh, applications. Okay, maybe combining several services. So, for example, if you want to build, I don't know, a service that at some point has to do proof verification, then you can integrate aligned for that part. And if you need, for example, data availability, you can have a data availability service like EigenDA. So I am really excited about the future of Ethereum, not only because we have this amazing community and tech, but also because we have the possibility to build new things without having to touch the base protocol. Okay, so I think that we will see lots of new ABSs thriving, and I think that with Aligned, we are going to help have like a much higher throughput because it's going to be easier also to maybe launch some rollups. We think that, of course, the landscape for Web3 is going to be perhaps significantly different from what we know right now, because we are going to find like ways of solving some of the big issues of Web3, such as interoperability, fragmentation, and of course, always the problem of scale. So yeah, in short, Eigen is like is crucial to have this very high throughput because we can build this decentralized network that basically runs um, the verification code natively. And so what we do is we avoid all the limitations of the EVM. So it's interesting because it allows you like to have some sort of like programmability on top of Ethereum without having to uh, deal directly with the EVM.
Thank you, Diego. We have like so many more questions, but we don't have enough time. So we'll get to those questions either in the next community call, or we will try to answer like these general subjects and questions that are asked a lot in some blog posts maybe. And if there are more questions, you can put them in the chat now, and we'll try to answer a few of them before we wrap up. Cool. Let's fucking go. Yes. Yeah, we have crossed 1,000 members. How many team members in Aligned? Ooh, there's quite some, actually. I think there's quite so many engineers. I think it's over 25 or 30 people now. We cannot invite on stage this time, but next time we could, if we have more time left, we can invite. How Erna, we will be distributing POAPs to the people who joined today and the next community calls. I suggest you all claim them because it will be a good way for us to track who's been participating in the community calls. Please talk with energy. I'm sorry. I'm excited. It's my first community call.
Mine too.
I think we don't have any more questions in the chat. Oh, wait, we do have one interesting question. After blob upgrade, L1 and L2 already cut the cost of fee. Then how Aligned is going to fit in for this? It says.
No, but the good part is we are reducing the part that doesn't have to do with the data. Okay, so if you take a look when you send, I don't know, check in Ethereum, maybe look for a Gross 16, Plonk, Stark Proof, whatever you like, you'll see that it has a gas cost, which is the associated with the verification. Typically, what they do is that they try to compress like the public input and all that to reduce the costs for posting data to Ethereum, but that is the cost you have to pay just for verification, which is like 250, 400,000, more than 1 million, okay? So that is the cost we are actually reducing. And the advantage is since we use our batching strategy and all that, we avoid having to publish all the data related to the proofs to Ethereum. Okay, we just post what we call a commitment to all the data. And then with fast mode, okay, then we have this signature that we have to verify. And that is the cost you are going to pay for the proof, divided by all the proofs that are contained in the batch. Okay, so that's why you get a reduction from the cost you have like right now. Even considering the update for blobs and all that, you still have to pay this 250K because it's related to, for example, the pairing, the modexp, or whatever operation you have to do, or the Ketcha caching. And in the case of Aligned, what you can reduce is, of course, this large cost, which is, of course, when data availability was expensive, when data was expensive, of course, then you had even higher cost. But if you take a look at the cost they are paying right now in the L2s and everything, it's still quite high because of these verification cost, and that is what we are cutting really. So I think we fit perfectly to reduce costs. Right now, if you want to launch a rollup, maybe you need several $1 million just to verify proofs. And of course, if you get like in a bull market or something, it's going to be even more expensive. So cutting it just by an order of magnitude or more is already is like a huge saving.
Thank you. Okay, we don't have any more questions. Yes, the chat is funny. Thank you all for joining. And about the POAP, ISOP will be announcing it in a moment, how to claim it. Please do claim it, and make sure to join next week, the week after next week, for our second community call. We will be announcing more interesting things and answering more questions. How people are still asking how to claim. It will be announced in the announcements. Just watch the announcements, please, to claim the POAP. Thank you all, and thank you, Diego, for answering all our questions.
Thanks a lot. Nice having you all here. See you.
See you. Bye.